Hey there, YouTubers. I thought this would be especially appropriate, my little spooky ball here, but it's not turning on. Let me get that plugged in for you because I'm going to talk about Tesla a little bit, but mostly about just electrical theory themes. If you watched the previous video, you know that I've been at OSCON learning about electrical grids and the grid failures in California. And because World Game is so much into electrical matters, World Game is a concept developed by Buckminster Fuller, and he tells the history and critical path of the spread of the rural electrification project. Now, when we learn history, how do we learn it? Do we learn the history of ideas? Do we learn the history of inventions? Or is it about battles and politicians? I've found Critical Path by R. Buckminster Fuller to be refreshing because the backbone of that narrative is the development of maritime technology. And whether we agree on the details of how Fuller tells his story, I found it refreshing simply to take that angle, that we would tell the story of humanity more in terms of this other kind of hero, these innovators and so forth. Now, part of my follow-up studies, having heard about the California grid woes and plans for the future, open source in some dimensions, I dove into Eric Dollard's work. I don't remember exactly how he came up in my search. And I don't agree with all the things he says. Like, I was just talking to a former NASA guy and running by him Dollard's claim that you don't see the stars when you're in space. Well, what about the Hubble? And of course you do. It's just that cameras on the moon, in trying to get the exposure right, they need to compensate for the glare of the moon's surface. So they stop down the aperture and all that. So there we have a black sky. But I don't think that going into space involves the stars or the sun becoming invisible, the sun being a star. Anyway, I'm like not becoming a mindless acceptor of Eric Dollard's claims in every case, but he turned me on to electrical genius Charles Proteus Steinmetz. Now, so here I am looking at a documentary. This one is interesting because the remastered so-called version has a lot of inserted imagery and so forth. And then it's clearly like the original documentary, which is rather old and dated, but interesting, more interesting because of that. And then there's some remastering, quote unquote, going on. Anyway, I recommend this. Only 16, almost 17,000 views. I would think more. Like, this guy Steinmetz should not be forgotten. We hear about Tesla, we hear about Edison versus Tesla. This guy worked for General Electric and seemed to have a pretty happy life, which was uplifting because I've been getting only a lot of bad news lately. So this was useful. So Dollard, if you're not familiar with him, seems to be doing okay right now. Like, I did some follow up. I'm interested in his thinking simply because I think we don't do enough in science to make namespaces okay. And what do I mean by that? Well, in computer science, we know that everybody wants to use the same keywords, the same cool words, like gravity, like vector. Like, if you want to make your mark or you want to write your module in Python, you don't want to use silly words. Like I've said before, it's a silly philosophical sort of position that if you don't mean what we all mean by gravity, then you should say schmavity, right? Like, you're going to be relegated to these silly words if you can't bring yourself to mean exactly what we all mean. But what do we all mean by gravity? You know, there's been so many debates and bitter debates in some cases about spooky action at a distance and space-time warping and, Einstein and all this. What is gravity? I think we're still working on it, right? The galaxies don't behave properly according to gravitational theory, so dark matter has been postulated to save the theory of gravity as we know it now. It's only telling me that we have a long way to go. And yet we'll keep using all these same key words. We'll just morph their meaning as time goes on. And that tells me that namespaces, we need to accept, like in religion, also in science, different thinkers, different geniuses create different systems. And they can all mutually survive. It's not like we have to winnow it out. And I think Darwinian thinking has been taken too far, and we think that there can only be one theory of anything. And why not choose the more Git being version control, GitHub and all that? Why not look at it more like we can have multiple branches, and we can afford to support more than one branch? Along those lines, I wanted to bring up the History of Vector Analysis as a great book by Michael Crow. Sorry if I got that wrong, Crowe. I've read this before. I took it on the bus today, along with I Seem to Be a Verb by Fuller and Company. This was my bus reading. I went to El Mercado. Got more bad news there. Some owners there are thinking they're going to have to, for some reason, double and triple the rents on a thriving set of businesses that aren't going to be able to afford that. So that looks pretty dismal now all of a sudden. Greed takes over on so many dimensions, something Fuller was fighting about. So quadrats, I think they belong in the history of vector analysis in some way, and you can just look at them as a sort of a silly toy in a way. You don't have to take them super seriously. You don't have to look at them as a threat. They're not going to hurt anybody, but they do have an interesting set of properties. Vector addition is done the same way as usual, tip to tail, and vector subtraction, again, same as usual. And I recommend looking into quadrats, in part only because they help give us insight into what Fuller meant by 4D. And here in my blog, once again, I talk about dimension again. And I have two YouTubes. This will be July 16th, 2019, where I talk through the same set of slides in two different ways at two different times, proving my point that you too could talk through the same slides and give yet a different narrative. The thing about quadrats is they help us understand Fuller's namespace. And again, I think we have room for multiple namespaces even in science. It's not about building the one and only true church. It's not a threat to have multiple religions. It's not a threat to let somebody like Dollard try to continue the thinking of Steinmetz and develop those mnemonics. I think of mnemonics as what we're doing in science. We're giving a way to think about. And if it works in the practical dimensions, if you can get work done and you can sort of prove your points at some level, something is working. Like with Fuller, we got a lot of useful inventions that actually do real work in the real world. Well, that's another good reason not to turn your back on this branch. Multiple branches are okay. Multiple namespaces are okay. Don't be so threatened when we come to your curriculum advisors and say, hey, why don't you include the whole number volumes from the Fuller literature? Why not include that in your math curriculum? And you're like, well, that's not what we're teaching. That's different. We can't have more than one way to approach geometry, and that's exactly what we need to get over. As you'll see from this book on the history of vector analysis, for example, what Hamilton thought was his greatest invention in a lot of ways, quaternions, Where did they end up? Have they been that important? Does everybody use them in physics? The answer is not yet, not now, maybe someday. But we don't necessarily have to let all this sort of not currently mainstream stuff go to waste just because it's not currently mainstream. And we see the same trend with the media. The so-called mainstream media are being challenged a lot, right? There's other media now that's not mainstream. So that's not a big problem. I think it's the sense of scarcity and the sense that funding can only go to a certain finite number of individuals. And if you're sort of on the sidelines with a less popular theory, a more marginal model, then you don't have a chance at getting a slice of the funding, and therefore, your life will be miserable. And patronage and sponsorship, I think, are unfortunately diminishing science and diminishing open source. So we need to get back to general systems theory, back to the UBI idea, or research fellowships for all, universal basic income. We could call that Social Security for all. Just like they're saying Medicare for all, they're taking something normally considered an entitlement for older folks and saying, let's give Medicare for all. Well, let's give Social Security for all, safety net for all. The idea that humans would do better, not worse, if they had time to think, catch up, do research, work on their projects. I think, it's very selfish to make everybody have to bow down and serve a few masters. But currently we still have a Malthusian take on the world, which Fuller was very good at challenging. And we think that, oh no, you first have to make a big fortune, you have to strike it rich, and then you can indulge in your research, right? I think we need to get over that somehow. And I know that the people who do blockchain are hoping they can help us get over that. And GoFundMe, and in my case, Coffee Shops Network. If you haven't looked into that, check it out. That's where you win at certain games and you give your winnings to the cause or project of your choice, and you get to take credit for that because you won the game, and you get to build your profile based on what projects you support. So it's a way of making philanthropy something we all can engage in, and not just people who've made a fortune. And then they, and only they, get to know what philanthropy is all about. We need to democratize philanthropy. Coffee Shops Network, check it out. All right, talk to you soon.